to demonstrate how Sql injection works. So here we were able to type in some SQL code into this input field, do a search, and then we were able to gain access to parts of the database that we weren't meant to see, namely the users and their passwords. So in this case, I'm showing you the absolute worst scenario. Here we have the password stored in plain text. So a hacker could now try out the password rainbows, log in as Kermit, and then maybe even find out if Kermit used this password other places, such as in his bank account. So what we want to talk about now is how can we continue to protect our users' passwords even if somebody did gain access to the database. So in order to do that, we'll have to hash these passwords. That means that instead of seeing these passwords in plain text, we want to hash them so that they're just random strings. And anybody who sees these strings, they won't be able to do anything with them. They're just going to be meaningless nonsense. Okay, so I said that we're going to be using a hash, and hashing often gets confused with encryption. So let's just take a moment to clarify the two terms. So hashing is a one-way process, whereas encryption is a two-way process. So let's use an example to clarify what we mean by that. So something that may be encrypted, for example, is credit card information. So if I type in my credit card information into a website, it's because I'm purchasing something and I want that other party to know what my credit card information is. But I don't want everybody to know. And so behind the scenes, the website's going to encrypt the data, meaning that anybody who happens to get their hands on this, they will not be able to find out what the original credit card information was. So the credit card data gets encrypted, and then it can be turned back into the original credit card information, but only if you have the encryption key. So it takes the key in order to take that encrypted data and turn it back into credit card information. So that's what encryption is, but we don't want to do this with passwords. With passwords, you get a password and you turn it into a hash, and that's the only way you can go. There's no such thing as a hashing key. You can't take the hash and find out what the original password was. So in that case, well, what good is it? So the thing about hashing is that it's consistent, meaning that the same data produces the same hash. So if we hash a password twice, then we should see the exact same hash being produced. Okay, so let's walk through how this would be used on a website. So let's say that we're registering at a website, right? It's our very first time there. And we have to register, we fill out the form, we type in our password information, and behind the scenes, the server is going to take that password and hash it. And the hash is what gets stored in the database, not the actual password, only the hash. So no human eyes should ever see what that password is. We get that password, we hash it, and put the hash in the database. That's it. That's all that we're going to do with the password. So then how does somebody log in? So in order to log in, right, you have to type in your password. And we said here that the same data produces the same hash. Okay, so here we come again. We have that password, right, and we'll do it again. Password into hash. And then we can see if that hash matches the one that we have in the database. All right, so this hash that came in from login, we're going to compare it to the one from registration, and we're going to see if they're equal to each other. So that's how hashing works, right? So it's a one-way process, and no one should ever know what a user's password is. Not the web developers, not the owner of the website, no one. So if you're ever on a website and you say, oh, I forgot my password, and you click that little I forgot my password link, and if they email you your password, that is terrible. That is absolutely awful. Get out of there. You never, ever, ever want anybody to know your password, not even the people you gave it to. Okay, so they should only have the hash, and they should not be able to figure out what your password was from that hash. Okay, so in order to make this happen, we're going to be using some hashing algorithms. The one that we're going to be using is called bcrypt. Okay, that's the one that we want to use. However, in order to really understand how bcrypt works, we're going to be taking a look at some other ones. MD5 is the one that we'll be looking at. There's also another very common hashing algorithm called SHA-1. However, these ones, they're kind of expired, all right? They're too common and not really useful anymore. But they have a pretty interesting story to tell. So we're going to be looking into the history of MD5 because we can see how we've had to evolve and adjust to hackers' attempts to get into databases. Okay, so we're going to take a look at the technique of MD5, how hackers can get around it, how we changed in order to thwart the hackers, and then how the hackers got around that one. And ultimately, that brings us to bcrypt. Okay, so in order to appreciate bcrypt, we'll spend a little bit of time talking about the history of MD5. As discussed, you should never store your passwords in plain text here. We should instead be hashing the passwords so that if somebody were to break into your database, as I did here, we would only see long random strings. Now, you might think that that would keep you safe. After all, what could we possibly do with a long random string? Well, let's think like a hacker here. So as a hacker, I would probably gather all the data that I possibly could, including the hashed password, and I would put that in a Python dictionary. So something like this. Here I made a Python dictionary that I'm calling user table, and the keys are the password hashes, and the values are the usernames. Of course, I could gather a lot more data and put that in the value as well, but for now, we'll just keep it simple. So having done this, I may then think about how there are a lot of passwords out there that people continue to use, even though they know it's a bad idea. Passwords like password or let me in. These are very, very common passwords. And if I had a whole lot of passwords from someone's database, there's a good chance that some common passwords are in there. So if I have my list of passwords that I want to check, then I can very quickly write a little for loop, and my computer's really fast, MD5 is really fast, we can blaze through and hash all of these things and see if our hash shows up in this user table. So if I suspect that a website is using MD5, and it's a very popular hashing algorithm, then, well, I can use MD5 too. And so I can hash my passwords and see if they match what's in the user table. So in pseudocode, it would look something like this. I would go through every password in my passwords to check list, and I would hash the password using MD5. And I would check if that is in the user table, then I would probably just want to print it so that I can refer to it later. So this is just pseudocode, so that's not actually going to work, but it's the basic structure that we need. The actual code that we need is this. And it's just a little bit more complicated to use MD5 than what I was using before. Okay, so here's my code, and so let's give it a try. Let's see if any of these passwords here are actually here in the user table. So I'm going to run this with Python, and indeed we found 3 passwords. Password with 5s, and let me in. Knowing that hackers could just brute force their way through using MD5 and find common passwords that may appear in our database, we have to get a bit smarter. So let's talk about the idea of a salt. A salt is just a long random string, and that really would be the ideal password, just a long random string of characters. Okay, that would be great. Unfortunately, nobody has that for their password because you can't remember it. Okay, so we're going to do that for our users then. So in our server, we're just going to store a salt. And let's say that that salt is something like E56888B1FG993KMS5. Okay, just some long random string. Now it doesn't matter if they're using a password like password, because we're just going to add this salt on for them. So we keep this salt in our server. They come along with their miserable password of password, but we're going to concatenate on the salt, and then we'll pass it to the MD5 hashing algorithm, and we'll discover our hash. So now that method that hackers were using, where they were just guessing common passwords, it's just not going to work, right? Okay, well, it's a good thought. However, hackers can also break into your server. And so all it takes is a hacker to break into your server and find what that salt is. And then it's going to be just as easy as ever. They can make their user table, like we have here. And then we would just have to make a little adjustment to our algorithm. So we would say for password in passwords to check, as before, we would have that. And then we would just hash the password plus the salt. And maybe it would take a couple guesses. Maybe we put the salt in the front, maybe we put the salt in the back. So it may take a couple guesses, but we could pretty quickly figure out if That's if we have our passwords using that salt. So there you have it. It's a good idea as long as you can be certain that that salt is kept safe. But we're talking about hackers here, and they might break into your server and find that salt. So let's just look at the real code. So here's what I would do, and let's run this and see if we can find any of these passwords in this user table. So we're going to do hash password salt. Okay. And there we go. We found our 3 passwords. So our idea of salting everybody's password didn't really work out. It's just too risky that somebody could break into our server and find our salt, and then we're right back at square one, where they're able to write a simple for loop and brute force their way through and find the common passwords. But salting is such a good idea. So what can we do instead? Well, we can give each user their own salt. How about that? What if each user gets a salt? Then how would we remember which salt belongs to which user? Well, I'd have to go into the database. So now our users table would look something like this. We'd still have our ID, we'd still have things like first name, last name, all those things. We would still have the password hash, and we would have the salt that was used to help produce that hash. So you might be thinking, well, this is crazy. Okay, at least last time a hacker had to break into the database and they had to break into the server to find the salt. But now you're saying that we just have to break into the database and we'll have all the salts? Seems nuts. But it's actually a really good idea, because the point is not to keep the salt secret. The point is we're going to slow the hackers way down. So just think about the algorithm that would be necessary now in order to try to find the common passwords. Okay, so now the salts all belong to the different users. So we want to try out each password with each salt. That means that we need a nested for loop. So we're going to look through the users. And again, this is just pseudocode, but the basic idea is we have to loop through all the users, and then we would have to loop through all of the passwords that we want to try out. So there's our nested for loop. And then what we're going to hash is the password that we're on with the user's salt that we're on. So we would MD5 the password plus the user's salt. And we would check if that is in our user table. So this nested for loop right here would just really destroy the morale of any hacker. So remember that when we hack into a database, we're going into a database that probably has thousands and thousands and thousands of users, and we probably have a lot of passwords that we want to try. So this could really take a very, very, very long time. Okay, so let's just take a look at some real code. So we're going to take a peek at this right here. What we did is we have this user table. The hashes are the keys, as before. But this time the value is a dictionary itself. We have the salt, and we also have the username. So our actual nested for loop looks like this, where we're going through all the values in the user table. We're looking through all of the passwords that we want to check, and we're hashing the password plus the value, the salt that's in the value that we're looking at. And so if we run this, then yeah, we're going to find some passwords. Like this code would work, but our dictionary is also pretty small. So in real life, if this dictionary had thousands and thousands, maybe millions of users in there, then this would have taken a really, really long time to run. So there's the idea there. Our main strategy that we want to use is we want to slow the hackers down from their brute force attempts. So we're not actually going to use MD5. MD5 is a really, really fast algorithm, and we're just trying to trick it into being slow. But there are algorithms out there that are actually slow. So bcrypt is slow. So it's designed to be slow. So that's why we're going to be using bcrypt. It borrows a lot of the techniques that we talked about with the idea of the salt and everything like that. But it's actually a very, very slow algorithm. Not so slow that an honest user would notice any change, but much slower so that it's just not going to be worth it to a hacker to try to brute force their way through your database.